Okay, so copy the trapezoid at the right on your paper, then determine its area and perimeter. The formula for the area of a trapezoid was B1 plus B2 times the height. And realistically speaking, that's not our issue. The hard part about this is finding the perimeter, because I was looking at this and I was like, what? So let's do the area first so we can just get it out of the way. And we'll come back to the perimeter in a second. So the area for the trapezoid formula was B1 plus B2, so base 1 plus base 2 times the height, all divided by 2. So you can plug that in, and your base 1 is 15, your base 2 is 22, times the height, which is 4, divided by 2. You should be able to get that answer. All right, perimeter. You're missing a couple of things. You're missing, obviously, the two edges. I personally don't think this is an isosceles trapezoid, so I'm a little confused how they want us to do this. So I'm sort of going to kind of wing this right now. I know this is from here to here, it's 15, right? Okay. From here to here, it's 15. Oh, I just got it. Okay. All right, I'm cool. All right, so we need this part. Let's call it X. And then using this triangle, we're also going to find this little part right here, Y. So I'm going to call it the little purple part. Okay, we're going to find that too. So let's set this up. I'm going to copy the triangle on... I'm going to copy this triangle over here. So we have a 45-degree triangle. We know this is 4. That's a right angle. This is our Y, and this is our X. Okay, perfect. Woo, we're good. We got trig up our sleeve. So 45 degrees, opposite, and adjacent. So tangent of 45 degrees is opposite, which is 4 over Y. Tangent 45 degrees is, I believe, square root of 2 over 2, but I'm going to use tangent 45. Oh, I lied. It's 1. 4 over Y. So 1 over 1 is equal to 4 over Y. So 1 times Y is just Y, and 1 times 4 is just 4. So Y has to be 4. There's no other way around it. Okay, well that was easy. All right, and then X. All right, so if Y equals to 4, and this is 4, if you really want to use trig, we can use trig. We could do 4 and X. So that would be sine and opposite and hypotenuse. So sine of 45 degrees is equal to, opposite is 4, hypotenuse is X, sine of 45 degrees, that one's square root of 2 over 2. So sine of 45 degrees is going to be a funky decimal, so 0.7071 is equal to 4 over X. So that means X is equal to 4 divided by 0.7071. So 4 divided by second answer is going to be 5.65. Okay, I'm just going to round 5.65, 6, what is this, 9? I like decimals, so I'm going to go with the decimals. I think it says keep your work organized so you can later explain how you solved it, but keep it together. So you're fine. So now you know X is 5.6569, so X is going to be 5.6569. Okay, that helps. So we know this little piece is 4. If the whole thing is 22, that part is 15. 4 plus 15 is going to give us 19. So 22 minus 19 is going to give us 3. So in this part over here, this is 3. This is, again, a 90-degree angle. We know this is 4 because it's just the same height on the other side. So this is going to be a 3-4 triangle. Oh, this is going to be a piece of cakes. So this is going to be 3 squared, 4 squared is 16. 3 squared is 9, 9 to 16 is 25. The square root of 25 is going to be 5. So this is a 3, 4, 5 Pythagorean triple. So if you don't believe me, you can do your Pythagorean theorem, put 3 on the 4, and you should be fine. Now, that's 5. So there you go. That's your perimeter. So add up all the edges, and you're fine. You're done with your perimeter. So 15 plus 22 plus 5 plus 5.6569, and then you should be done with your perimeter. Okay, that was 90. And then the last one, number 91. And I must say, I have to apologize for giving so much homework. But, well, it is what it is. Examine the diagram at the right. Write an equation representing the relationship of the sides using x, y's, and r. And this is by far the most interesting and, well, I think it's an interesting problem out of the whole bunch that we just did. So, you have theta, which is your angle. Write an expression for sine of theta. It just basically means what numbers would you use, or what letters would you use if you were to set up a sine proportion. So sine was opposite over hypotenuse, and opposite the theta is the y, and your hypotenuse is r. So that means sine of theta, in this case, is going to be nothing but opposite, which is y, over your hypotenuse, which is r. That's it. Okay, that's an expression for sine of theta using this triangle. Now, if r is equal to 1, then technically sine of theta is going to be equal to y over 1, which just basically means that sine of theta is equal to y. There you go. If r was equal to 1. Now, cosine. Cosine of theta was adjacent over hypotenuse, so x over r. But if r is equal to 1, then cosine of theta is x over 1. I just substituted, which means that x over 1 is just the same as x. So cosine of theta would be equal to x. Now, these two here, it's a little early in the game, don't get me wrong, but these two here are going to be huge in Math 3. The fact that y, or the vertical change in this triangle, is synonymous with sine of theta, and the horizontal change in this triangle is actually synonymous with cosine theta. And there you go. So hopefully that helped.